Okay, we're going to talk. Okay, we're going to talk about acyl chlorides today. Okay, now acyl chlorides, sorry. Acyl chlorides, sometimes called acid chlorides. Right, they're a derivative of carboxylic acids. So if we have a carboxylic acid would be like this. And it's got an OH group on there. Right, so an acyl chloride would be like this. So it's got a carbonyl group, but instead of the OH, it has a chlorine atom there. Now these are more reactive versions of carboxylic acids. You can react an acyl chloride with an alcohol to form an ester, and the mechanism will be exactly the same. The mechanism will be nucleophilic addition elimination. Okay, so let's just see how this works. Okay, so we've got a delta positive on this carbon. We've got a delta positive on this carbon. Now, when they react with alcohols, so if I draw an alcohol, and I'll draw the alcohol, let's make it methanol. This one's going to react with methanol. Okay, so the first step in the reaction mechanism would be for the lone pair on the oxygen to attack the carbonyl carbon. Exactly the same thing happens here. That attacks the carbonyl carbon. And of course the same, because that carbon will now be forming 5 bonds, the pi bond will break here. Same here, the pi bond breaks, a pair of electrons goes onto the oxygen. So if I carry on with the acyl chloride, then we're going to end up with this intermediate. So you have a negatively charged oxygen, the chlorine still attached. We have a positively charged oxygen there. Okay, now if you remember what happened with the reaction with the carboxylic acid, the next step of the mechanism is for the lone pair on the oxygen reforms the pi bond, and then the bond here, in this case, with the carboxylic acid, the bond to the OH breaks. In this case, it's the bond to the Cl that breaks. Okay. So if I draw now, what we've got left is we've got and the final step in the mechanism is just for this hydrogen to come off. So that pair of electrons goes back into the oxygen and we form the ester. So we've formed an ester there. Just to talk again, what happens to this chlorine? Well, that chlorine is going to come off as Cl minus here. And this hydrogen is going to come off here as H plus. So effectively, we've eliminated a molecule of HCl. Okay, so if we react the ester, we react from the ester, we can either do that by using a carboxylic acid and the alcohol, or with an acyl chloride and the alcohol. The reaction with the acyl chloride is much faster. Also, the reaction with the acyl chloride tends to go to completion. You get a very high yield. If you react the carboxylic acid with an alcohol, it's an equilibrium reaction, and you're never going to get a very good yield. One of the reasons for this is that this step in the mechanism where you have the chlorine comes off as a chloride ion, or the OH comes off as an OH minus ion. This is called a good leaving group. The chlorine is much happier to drop off and form the chloride ion than the OH minus is to form the hydroxide ion. And this is what makes what drives the mechanism forward, will make the reaction go to completion rather than forming an equilibrium reaction. Okay, so let's just summarize that. So carboxylic acid, so you get that, plus the alcohol. By putting a little tick on that R, it means that it doesn't necessarily have to be the same R group as that. So for example, that might be a methyl group, this could be an ethyl group, or that could be propyl, that could be so on, yeah. So it's an equilibrium reaction. We're going to get the ester as a product. And the molecule that is eliminated is where we lose a molecule of water, H2O. With the acyl chloride, you'll get it's not an equilibrium reaction, effectively it goes to completion. You get the ester, and you get HCl. Let's just write it down. Slow equilibrium reaction, whereas this one is fast. It goes to completion. So you get the same product, the same ester. Same ester in each case. The only difference is you get a different small molecule eliminated here. You get water, and with this one you get HCl. Okay, let's just a quick about naming acyl chlorides. So this one you would call ethanoyl chloride. If it had an extra carbon on it, that would be propanoyl chloride. And so on. Okay, more about acyl chlorides in the next lesson then.